In the DLI project DiCADeMa, we establish a digital connection between the design process and the manufacturing of carbon structures. In this way, we are enabling design customization even until the very last moment.
In our use case, we decide on a new cabin configuration, for example, by changing the seat spacing or the positioning of the monuments. And these changes are automatically taken into account when determining the mounting positions of the luggage compartments. Based on the new configuration, the exact position of the installation points are calculated and validated automatically. The corresponding production sequence is then proposed and simulated. Our digital methods are crucial to make it work. We can link every step from design to production on the shop floor. Every detail is taken into account as we model and connect each process in a seamless digital flow. It's like a digital thread running through all the steps. If we change one part, the rest adapts automatically. This enables us to respond quickly and efficiently, even when last-minute changes come up. To validate our digital models, we use simulation. Using 3D models, we can identify and resolve problems early, before anything gets built. Once everything checks out, the production sequence is ready to be implemented in the real world. In this project, the execution part of the digital thread was exemplarily demonstrated with physical mock-up of the full-size frames using automated guided vehicle with a small robot mounted. The vehicle moves to the frame and the robot brings the 3D camera close to the target position and takes a picture. Using 3D point cloud from picture and the CAD model of the frame, the exact position and offset is calculated, allowing highly precise positioning for the marking of the installation point. A human worker will follow the vehicle and drill the hole directly after the position has been marked. This process is repeated for every installation point, while robot and human can operate safely in close proximity. This demonstration is just one example of the technologies for precise and autonomous manufacturing we are developing at DLR. The results achieved in the project DiCADeMa increase the level of digitalization in modern aircraft manufacturing. This in turn leads to benefits like higher precision and quality, automated documentation and traceability, as well as a significant reduction of production time. The developed digital process itself is a blueprint that could be adapted to any kind of shop floor environment and technical solutions using common data interfaces.